Okay, we're going to continue on our work with the discriminant from last day. Okay, remember that the discriminant is given by b squared minus 4ac, and you need to identify a, b, and c. Okay, so let's start off with a familiar one. 2x squared minus 5x minus 3. Okay, so let's identify a, b, and c. Okay, so we can see that a is 2, and b is minus 5, and c is minus 3. Okay, so we're going to state the nature of the roots by calculating the discriminant. B squared minus 4ac, which b is minus 5, so it's minus 5 squared, minus 4 times a, which is 2, times c, which is minus 3. Minus 5 squared is 25, and then minus 4 times 2 is minus 8, and minus 8 times minus 3 is plus 24. Okay, 25 plus 24 is 49. Okay, let's just go over that again. Okay, identify a, b, and c. 2 minus 5 minus 3. Okay, b squared minus 4ac was b is minus 5, so it's minus 5 squared minus 4 times a times c, minus 4 times 2 times minus 3. You square a negative, you get a positive. Minus 5 squared is 25, and then minus 4 times 2 is minus 8. Minus 8 times minus 3 is plus 24. 25 plus 24 is 49 finally. Okay, now with the discriminant, you need to ensure that the thing is equal to 0. Okay, so all examples for the discriminant should be equal to 0. Now, if it's not equal to 0, you need to make it equal to 0. Okay, so ideally what we want with this equation is an equals 0 at the end. We don't, we've got an equals 4, so what we need to do is move that 4 across and change its sign. So that's called change side, change sign. Okay, we've done a wee bit of that before with quadratic equations. Now, all that means is if you move something from one side of the equal sign to the other, it changes its sign. So a 4 would become a minus 4. So now look at 3x squared plus 5x minus 4 is equal to 0. Okay, so we move the 4 from one side of the equal sign to the other, which leaves me with 0 over here, and 4 becomes minus 4. I can now identify a, b, and c. A is 3, b's 5 rather, and c's minus 4. A is 3, b is 5, c is minus 4. B squared minus 4ac. Okay, so b squared minus 4ac was b. B is 5, so that's 5 squared. Minus 4 times a, which is 3, times c, which is minus 4. 5 squared is 25. And then I've got minus 4 times 3 is minus 12. Minus 12 times minus 4 is plus 48. 25 plus 48, that's 73. Okay, 73 is greater than 0, which means b squared minus 4ac is greater than 0. Therefore, roots are real and distinct. Just before we go any further, let's just remind ourselves of the conditions of the discriminant. Alright, if you find the discriminant to be greater than 0, that means that the roots are real and distinct. And that is when the discriminant is greater than 0. When the discriminant is equal to 0, that means that the roots are real and equal. Let's copy that down and have that in front of you with these examples. When the discriminant is less than 0, the roots are non-real. Have that in front of you for the next few examples. Okay, so when it's greater than 0, the roots are real and distinct. When it's equal to 0, the roots are real and equal. When it's less than 0, the roots are non-real. Okay, let's try an example 3. Okay, 4x squared plus 3x is equal to minus 1. Okay, first thing is we need the thing to be equal to 0, so we need to bring that minus 1 across and when it comes across it will become plus 1. 4x squared plus 3x plus 1 equals 0. There's A, 4. There's B, that's 3. And there's C, that's 1. Next move, B squared minus 4AC. What's B? B is 3, so it's 3 squared minus 4 times A, which is 4, times C, which is 1. 3 squared is 9, and then it's minus, well, 4 times 4 is 16, and 16 times 1 is 16, minus 16, minus 7. So what does that mean? It's less than 0, the roots are non-real. So minus 7 is less than 0. B squared minus 4AC then is less than 0. Therefore, roots are non-real. Example 4. Okay, example 4. 2x squared minus 5x equals 3. First move, you need to make the thing equal to 0, so you need to bring that 3 across, make it minus 3. So that's 2x squared minus 5x minus 3 is equal to 0. Then you get A, B and C. A is 2, B is minus 5 and C is minus 3. Next move, B squared minus 4AC. What's B? B is minus 5, so that's minus 5 squared minus 4 times A, which is 2, times C, which is minus 3. Minus 5 squared is 25. Take your time. Minus 4 times 2 is minus 8. Minus 8 times minus 3 is plus 24. 25 plus 24 is 49. 49 is greater than 0. B squared minus 4AC is greater than 0. Therefore, roots are what's greater than 0. So what's that again? Real and distinct. Okay, example 5. 3x squared equals 2x minus 1. Okay, now I need to make the thing equal to 0, so this time I'm going to have to move two things. I'm going to have to move the 2x across, it becomes minus 2x. I'm going to have to move the minus 1 across, it becomes plus 1. So 3x squared stays where it is. 2x comes across, it becomes minus 2x. Minus 1 comes across, it becomes plus 1. And that's equal to 0. A, B, C. A is 3, B is minus 2, C is 1. B squared minus 4AC. What's B? Minus 2, so it's minus 2 squared minus 4 times A, which is 3, times C, which is 1. Minus 2 squared is 4, and then it's minus 4 times 3 is 12, minus 12. Minus 12 times 1 is minus 12. 4 minus 12 is minus 8. Minus 8 is less than 0. So the discriminant then B squared minus 4AC is less than 0. Therefore, roots are non-real. Let's try one final example. Okay, x squared equals minus x plus 9. Okay, I need to make the thing equal to 0. Bring the minus x across, becomes plus x. Bring the plus 9 across, becomes minus 9. X squared plus x minus 9 equals 0. Now, why am I changing side? Changing sign, because I'm changing the side from the equal sign. Okay. Now, I need to identify A, B, and C. What's A? 1. What's B? 1 again. What's C? Minus 9. A's 1. B's 1. C's minus 9. Straight to it. B squared minus 4AC. What's B? 1. 1 squared minus 4 times A, which is 1, times C, which is minus 9. 1 squared is 1. Minus 4 times 1 is minus 4. Minus 4 times minus 9 is plus 36. That's 37. 37 is greater than 0. B squared minus 4AC is greater than 0. Therefore, roots are real and distinct. Okay, now you're going to try these ones. Okay, to try these ones, maybe your first move is to bring everything across and make it equal to 0. Change the signs when you do it. Identify a, b and c, b squared minus 4ac, make the calculation and make the statement at the end. Now, remember that you must make a statement at the end. So that statement is either going to be the roots are real and distinct, the roots are real and equal, or the roots are non-real.